Okay, so this is for Math 40. This is from section 6.8, Applications, another word problem. So we have a geometry problem. This one says that the length of a rectangle is 3 more than twice its width. The area is 44 inches. What is the length and width? So there's some key information in here. It tells us the length of a rectangle is 3 more than twice its width. And the other key information is that the area is 44 inches squared. So those are our two pieces of key information. So I always recommend that you make a little diagram. There's our little rectangle, and it's, as you see here, we have the length and we have the width. So here it tells us the length. It says the length of a rectangle is, that is means equal to, and it says 3 more. 3 more than means plus 3. And then it gives us some more information. It says 3 more than twice its width. So 2 times W. So we have the length is equal to 2 times W plus 3. That's twice the width plus 3. So the other piece of key information that we should remember is that the area is length times width. So keep that information in mind and let's work this out. So let's work from the area. So first let's rewrite the information that we know. We know that the length is equal to 2 times W plus 3. And we know that the area, 44 inches squared, is equal to length times width. And with that information, we're going to be able to solve this problem. This problem is easy to see if you've been going through chapter 4 lately, that we can substitute this expression L for that L that's in there, which means that we'll be left with only W's in our problem. So let's attempt to do that. I'll scoop this up. So we'll have 44 is equal to L. Well, L is equal to 2W plus 3. And then we have times W. So I'm going to switch things around using commutative property because I just want to be able to distribute this W in front of there. So I'm going to rewrite it as 44 is equal to W times 2W plus 3, and I'm going to distribute the W now. So I have 44 is equal to W times 2W is equal to 2W squared, and W times positive 3 is equal to plus 3W. Now this is looking close to something that we can solve. So what we need to do here is set this equation equal to 0 in order to solve for W. That means that we're going to subtract 44 from each side to set this equation equal to 0. Once we do that, we will have 0 is equal to 2W, line here, squared plus 3W minus 44. Now we can begin the process of factoring to solve this equation. So let's look here. We have 44. Its factors would include 4 and 11. Other factors would include 1 times 44 and 2 times 22. I'm looking here and I see that my sign is an opposite sign. The negative, it means that my factors are going to have opposite signs. And when I look here, I see that the larger sign, or the larger factor, is going to be positive. So let's try 2 and W. In order to get 2W squared, the only thing I can multiply together would be 2W times W. So now let's try to use this information to factor. So I have 2W and W. My signs are opposite, plus and minus, and I have 4 and 11. If I multiply the W times positive 4, I get positive 4W. The 2 times negative 11 would be minus 22W, which does not give us a difference of a positive 3. So that means I need to do this over again. So I'm going to switch the numbers. Make this top here 11 and this bottom here 4. And I'm going to keep my signs positive and negative. So I have 2 times 4, 2W times 4, which gives us a negative 4, which is negative 8W, and W times 11, which is equal to a positive 11W, which voila is equal to a positive 3W. So now I have my factors, which are 2W plus 11 and W minus 4. So now let's take that information and we're going to use it to solve the rest of our problem. So again, I had 2W plus 11 times W minus 4 equal to 0. So now I can set each of these factors equal to 0. My first factor is 2W plus 11. So I subtract 11 from both sides. That cancels. I get 2W is equal to negative 11. Divide by 2, and W is equal to negative 11 over 2. But if you know anything about geometry, you can't have a negative width or a negative length, which makes this answer in the real world untrue. It's not a real solution because we can't have a negative length or a negative width. It just doesn't make sense in the real world. So let's use our other factor, the W minus 4, and we'll solve for that. So we have W minus 4, set that equal to 0. Add 4 to both sides. This cancels. W is equal to 4. So our width is equal to 4 inches. So we use the original equation that we had for length, which was L is equal to 2W plus 3 to figure out what our length is going to be, and we plug in the information. So here we have length is equal to 2 times 4 plus 3. Length is equal to 8 plus 3. So our length is equal to 11 inches. And we are done.